Okay, welcome back for part 2 of the lesson, of lesson number 2. Still the same lesson, again, just the second part of it, because it's kind of long, we had to chop into 2 videos. So objective number 2 is to learn and apply some properties of addition and multiplication. Okay, addition and multiplication have a bunch of properties that we can use to help make problems easier for us to solve and things like that. So we're going to make a table again. Okay, and you're going to need 3 different columns, so we need a column here, and a column here, and a column here. Okay, we've got the name of the property. We're going to come up with a variable representation. Remember, our definition of a variable was a letter that can represent any number. Okay, and then we'll give you an example of the property. Now, when we do this, okay, I'm going to show you row by row what I'm talking about here. So here's the first property that we're going to talk about. Okay, now you may want to pause the video and write this down and then just listen. Okay, that might help you out while you're doing this. The first property is called the commutative property of addition. Okay, and what the commutative property says is that we can take numbers and add them in any order and it won't change what we get. Okay, so the variable representation is a plus b is the same as b plus a. So I took those two things and flipped them around, and it doesn't matter. I can do that. Okay, so let's test that over here in our example. My example I gave you says that 3 plus 4 is the same as 4 plus 3. Well, let's stop and think about if that's true or not. What is 3 plus 4? It's 7. What is 4 plus 3? It's 7. I got the same answer. Those are equal to each other. Okay, so again, commutative property says I can take the numbers and add them together in any order and it won't change what I have. Okay, well, there's a commutative property for addition. There's also a commutative property for multiplication that says the exact same thing. Okay, now notice in my table what I use for multiplication. So again, we got commutative property of multiplication. It's the same thing as the addition one. It says that we can take numbers and multiply them in any order and it doesn't change it. Okay, so my variable representation, I've got a times b equals b times a. Oh, but Mr. Ayers, you might be asking, I don't see the times sign. Remember, we just talked about this. We're getting away from using the x for times signs. We're using this little dot instead to represent times. And when we talk about the variables, you can see why that might be a good idea. Because if I put an x in here instead of a b, or instead of the dot, it would look like axb. Okay, it looks like 3 different letters. That's not what we want. We want to know it means times. So we put the little dot in. A times b equals b times a. Well, let's test this. Again, if I put numbers in, 3 times 4 is the same as if I flip that around. 4 times 3. Well, 3 times 4 is 12. 4 times 3 is 12. Those are equal. Okay, so commutative property works. Okay, so that's the commutative property. We have addition and multiplication. Okay, next property, it's called the associative property of addition. Okay, now again, you might want to stop this and write all this down and then just kind of listen and watch my explanation. That might help you out in this video. There's a lot of information on the screen right now. Okay, the associative property of addition says that I can take numbers and change the order I add them in. Okay, I can change how they're grouped. So these parentheses right here mean that those are grouped together. I have to add those together first and then add on another number. Well, the associative property says it doesn't matter how the numbers are grouped together. So here's how we represent that with variables. We have a plus b, meaning I would take a plus b first and then add on my third number, c. Okay, and they're telling us that's the same as if I flip those grouping symbols around. Remember, we always do parentheses first. So in this example over here, I would add b and c together first and then add a. Okay, because that's how the order of operations works. So let's test this theory. I'm saying that over here, if I add 3 plus 4 and I get 7 first, and then I add 5, okay, what would I get? Well, I'd get 12. Okay, that should be the same as if I solve this problem over here. Well, I have 3 plus 4 plus 5 again, but they're grouped differently. Okay, that means I have to do this 4 plus 5 first because it's in parentheses. So I'm going to take 3 plus, then what's 4 plus 5? Well, that's 9. And then what's 3 plus 9? That equals 12. Okay, Well, I got 12 on one side, I got 12 on the other side, so that means that the associative property works, that I can arrange or rearrange how I group those numbers together. Alright, and the associative property of multiplication is the same thing but for multiplying. Okay, so again, we've got our variable representation right here. Remember, the dots are for times. Again, all the parentheses mean is that's what numbers I should multiply together first. Okay, so if I look at the example, on the left-hand side, what would you do first over here? Okay, according to the order of operations, would you do 3 times 4 or 4 times 5? The correct answer should be you do 3 times 4, not because it comes first, but because it's in parentheses. Okay, so 3 times 4 is 12 times 5. Okay, and then we'll skip over to this other side over here. On this side over here, think about what would you do first to solve this side. Would you do 3 times 4 or 4 times 5? And think about why. Okay, you have to do 4 times 5 first because that's where the parentheses are on this one. So I'm going to leave my 3 alone and take that times, well, what's 4 times 5? That's 20. Okay? Well, now let's stop and see if this actually works. 12 times 5, okay, is 60. 3 times 20 is 60. Those two things are equal to each other, so the property works. Again, that's the associative property. It says that I can change how I group my numbers together to make them easier to multiply. Okay, now let's go to the next property. The identity property of addition. Okay, identity property of addition. All the identity property of addition says or lets us know is that we can take any number, and if we add 0 to it, we get the same number. Okay, well, that should make sense. So it's saying anything plus 0 is what you started with. So if I look over here, 3 plus 0 equals 3. That's the identity property of addition. Any number plus 0 equals itself. Okay, there's also an identity property of multiplication. Now for multiplication, it's the same thing, except we have to think about how can we take a number, how do I take a number and multiply it by something to get itself? Well, I take any number times 1, that gives me what I started with. Okay, so the identity of property of multiplication says any number times 1 equals itself. So over here we got 3 times 1 equals 3. Any number times 1 equals itself. Okay, now I'm going to slide this whole slide up a little bit so you can see the last one easier. The 0 property of multiplication is the last one. And the 0 property of multiplication, all it says is any number times 0 is 0. Okay, so again, 3 times 0 is 0. 5 times 0 would be 0. 80 million times 0 would still be 0. Okay, it doesn't matter. So those are the properties, and you're going to need to know those in the next couple examples. Okay, now we're going to use these properties to simplify expressions. Okay, it says justify each step. So since it says 2 ways, I put this little dividing bar in the middle. And we're going to show you 2 different ways to solve this. Okay, when we justify each step, that means write in words why you were able to do what you did. Okay, so the problem is 25 times 15 times 4. Well, all I did was rewrote the problem. So when I justify that, that's what I was given. Okay, so that is what I was given. Alright, now I could just solve this the exact same way, okay, that it shows it. That is one way that I could go about this. Okay, so the first thing that I would do to solve this problem is the parentheses. Okay, I would take 25 times 15. Well, 25 times 15 is 375. Okay, and then I would still have times 4. And the only thing that I did was I took 25 times 15. That's my justification. Okay, that's the step that I did. And I got 375. Now I wouldn't expect you guys to be able to do that in your head. Okay, that's fine. I would expect to see some work on the paper for that. Okay, well now I only have one thing left to do. 375 times 4. And that's 1,500. Okay, and again, the only thing I did there was I just multiplied what I was given. Okay, so those are my steps. That's my justification. Now, you might be thinking, Well, Mr. Ayers, why would I solve this problem any way other than that? Because that was a lot less work and a lot less steps. Okay, but you have to remember that you don't get to use calculators. So when you do 25 times 15, that's going to take a lot of work. All right. Same thing when you do 375 times 4. That's going to take a lot of work. So over here on the other side, I'm going to show you another way to solve this. And it might seem like it takes longer because there's more steps. But really, it's going to be a faster way because it involves kind of using your mathematical sense. Okay, so again, what I have here is what I was given. Now I might be looking at these three numbers saying, holy cow, I know what 25 times 4 is. Okay, because there's 4 quarters in a dollar, so 25 times 4 is 100. Okay, but I have to do some rearranging to be able to multiply those together. Okay, so first thing I could do is take these two things and flip them around. Okay, and make this 15 times 25 times 4. Okay, and do you remember what property that was? That was the commutative property of multiplication. Okay, so I'm writing the commutative property of multiplication. Make sure you specify. It's not the commutative property of addition, the commutative property of multiplication, because we're multiplying. It means that we can take those two numbers and flip them around. Okay, well, I've got parentheses. There's another property that said that I can rearrange the parentheses because I don't want to multiply 15 times 25 first. Okay, that's a hard problem. But I know 25 times 4. So there's a property that said that I can take these parentheses and move them and make this 15 times and then 25 times 4. And that was the associative property. Okay, let me try to write that again because that's just not very nice and neat. Sometimes Mr. Ayers struggles on his iPad. You'll find that out a little bit, but that's the associative property of multiplication. Okay, says that I can move those parentheses. Well, now to solve this, now according to the order of operations, I should do the parentheses first. And this is the whole reason I move these things around, is because I know what 25 times 4 is. That's 100. That's easy to me. So I created a much easier problem. And that's all I did, was 25 times 4. Now all I've got left is another easy problem. 15 times 100. Well, that's 1500 or 1500. And I justify that with the step on the side. Okay? Well, there you go. There's two different ways to solve the problem. This one over here looks like it's a little shorter, but by the time you do all that multiplying, that's a lot harder. Okay, it's really not. This one over here is probably the easier way, and it's the way that makes more sense mathematically because 25 times 4 is really easy, okay, to do. So there's two different ways to solve that problem. Make sure you show your steps on the side. Okay, we got the last two examples here for you. Objective number 3 says to use variables to represent missing or unknown values. Okay, that just means I want to use a letter to represent a number I don't know. Objective 4 says to find unknown numbers in equations by using inverse operations. Okay, inverse means opposite. Okay, so we're going to find the missing numbers by using inverse operations. So let's look at example 6, part A. Right here it says 6 plus x equals 30. Okay, well, to find that missing number, I need to do the inverse of adding. I'm going to subtract. Okay, and I'm going to take away the number I know on both sides. Okay, and I'm going to have x equals 30 minus 6 is 24. Okay, and that's it. So my answer should be x equals 24. All I did was I subtracted the 6 away from 30 because originally I had an addition problem. Alright, now let's go to part B. This is 6 times y equals 30. So I have to do the inverse of times. Well, what's the inverse of times? It's divide. Okay, so I'm going to divide by 6. And I get y equals, and 30 divided by 6 is 5. Okay, so inverse operations means just do the opposite of what you started with to get your answer. And you're finding an answer for a variable, for a letter that represents something you didn't know. Okay, but now we know what those are. Alright, well that's the end of lesson 2, part A and part B. I hope you enjoyed and got all your notes written down, and good luck on your homework.